Hello and welcome. So this is Mr. Buss. In this video, I'm going to walk through how to do the allele frequency calculations with the Hardy-Weinberg formula. And I just want to mention that you'll need at least a scientific calculator. So it doesn't have to be, a super expensive graphing calculator, but you'll need to have a square root function. And, it's good practice because on the AP test, May 14th in the spring here, you'll have access to a calculator. So it's good to practice using the same calculator on these worksheets that you'll actually have on the test itself. So let's see here, take a look at the worksheet. And all right, so allele frequency, this is Principles of Life textbook. If you're wanting to reference page numbers, about 298 to 299 or so. But I'll walk you through everything in this worksheet here. So we have these fun-looking equations, p squared plus 2pq plus q squared equals 1. That 1 just means, 100%. And this first line, this first equation here, is really referencing genotypes, where, so for this first problem here, it says like PTC, phenylthiocarbamide, is a bitter-tasting chemical that some people can taste, others cannot. Let's say that 36% of the population cannot taste PTC. Tasting is dominant. So for this, like tasting would be either capital T or capital T lowercase t. And then non-tasting would be recessive, which would be like lowercase t. So in this equation here, p squared is really just saying capital T. Didn't write that very well. Okay, that's just referring to the genotype. Okay, because there's two capital T's there. So P as an allele is just referring to just one capital T, versus Q squared is the lowercase t. Okay, and therefore just lowercase t would also be just Q there. So this one right here is the heterozygous version of the genotype, right? PQ would be like uppercase T, lowercase t. And again, the reason it's 2pq would be like if you did this cross here, two of them would be that heterozygous genotype, right? So that's why the number 2 is on there. Okay, let me just erase that. Okay, so Step 1, assign alleles and genotypes. And so this really walks you through these kinds of problems. When you get more used to doing them, you won't have to like fill out a whole chart and table and so on. But I do that for the first few problems to really get you used to how to solve these problems. So step 1, assign alleles. So again, P is the capital T, Q is the lowercase, and so on. So we have assigned alleles. All right, for those P and Q. All right, and then what we're going to do is we're going to start here, and we're going to work our way counterclockwise through these equations. It's not like you start with one and then just like solve it necessarily. So what is Q squared? Again, Q squared is that genotype. Okay, so as a decimal, what fraction, or not fraction, as a decimal, what's the frequency of the lowercase t genotype? And that's in the word problem. So it says that 36% of the population cannot taste PTC, which is the recessive trait. So 36% written as a decimal. Okay, so we're going to write percents as a decimal when you do these calculations. Otherwise, this would be 100% if we were going to use frequencies as a percent, which we're not. Okay, so we're going to use them as a decimal. So how do I go from Q squared to Q? Without even looking at equation, we should be able to solve that. We just unsquare Q. So if Q squared is 0.36, well, take the square root of 0.36. And it doesn't hurt to do that on your calculator because the square root of decimals is kind of confusing sometimes. So square root of 0.36 is 0.6. So 0.6 times 0.6 would give you 0.36. So we basically unsquared it for that one. All right, now how do we go from Q to P? How do we go from that column to that column? Well, we're going to use this equation. Notice that if we add up all of the capital T and lowercase t alleles in the population, obviously that will equal 100% or 1. So if we know that this is 0.6, well, what plus 0.6 equals 1? Well, that's 0.4, right? So that's how we solve that. We just take the difference of 1. So these two added up will always equal 1. All right. Okay, how do we move to the next line over now? How do we go from here to here? Well, we would just square p. So if p is 0.4, what's p squared? Well, 0.4 times 0.4 is 0.16. All right, so how do we do this last column then? Well, we're going to use, so where have we gone? We started here. We went counterclockwise. We got q, then we got p. Now we have p squared. And now all that's left is this one, 2pq. So if we know p squared is 0.16, and if we know q squared is 0.36, then we can solve this. All right, we just need to basically think about 2pq as just like being x or something like that. We're just solving for x, or we're solving for what we'd call 2pq. So we just add up what's 0.16 plus 0.36. That equals 0.52. So 0.52 plus what equals 1? 0.52 plus, this must be 0.48, right? So 2pq must be 0.48 to make this equation equal 1. 0.48. So these two numbers added up equal 1. That's p plus q equals 1. And these three numbers added up equal 1 because p squared plus 2pq plus q squared equals 1. So that's a way you can kind of double check your work. And sometimes in this, it might just ask for what's the heterozygous version and so on, which would be this one. So you might not always have to fill out a chart, but sometimes you have to kind of work through the problem this way in order to get to the answer. So again, like A, what is the frequency of the recessive allele? Let me go ahead and erase all this so that we can, again, the recessive, so this is that, this is, okay. So remember, that's what each of these columns represents. The frequency of the recessive allele is asking for Q, which is 0.6. The frequency of the dominant allele is 0.4. Percent of the population that are homozygous dominant. Oh, percent. Okay, so the decimal would be 0.16. So percent, if it asks for that, just to be specific, is 16%. Percent of the population is heterozygous would be 48%. And percent of the population that express the dominant phenotype. All right, that's the dominant phenotype. So 0.48 plus 0.16, 0.64, 64% since it's asking for a percent.